This is the vertical line test. Now, what does the vertical line test test? The vertical line test checks whether a curve in the coordinate plane is the graph of a function or not. In the first lesson and the second lesson, you can check those lessons over here. We spoke about functions as a vending machine. We spoke about functions as ice cubes in the refrigerator. We intuitively understood functions. We spoke about functions as the battery percentage of your phone, your laptop, or wherever you're watching this from. We spoke about functions as a horror movie that you're watching with your friends, Pennywise. But in order to understand the vertical line test, you need to know the difference between a function and a relation. Say I give you the Cartesian plane or the coordinate plane, and I give you this equation, f of x equals x squared. Well, you might be able to tell me that, hey, see ya, x squared, that's the equation of the parabola. And you would be right. It is the parabola, but we don't really care about the name of the function. We want to draw the function, so how do we do that? We need what's called the x and y coordinates, and in order to draw those, they're very simple. The first number in the bracket is called the x value, which comes from the x-axis or the horizontal line. And then the second number in the coordinates or in the brackets, that's called the y value, and it comes from the y-axis or the vertical line, and together they form what's called the coordinates. So we have 3 and 2 as a coordinate. We have -4 and 3 as a coordinate, -5, -4, and 2 and -5 right at the bottom. Well, okay, but what does all this coordinate stuff mean? This means that if we took the same function that we wanted to graph, that x squared, and we put in, say, number 2, the number 2 from the x-axis, we get 2 squared. 2 squared, it's 4. So the x value for the coordinates is 2, and the y value is 4. So if we had to express that in terms of coordinates, we're going to write 2 and 4, like that. We can try this with another number. We can try number 3. 3 squared is 9. That 3 is the 3 we put in from the x values, the x-axis, and that 9 is the y value. So if we are to put that as a coordinate, it's going to be 3 and 9. Now we're going to use this coordinates, not the exact same ones, but this concept of coordinates to graph that function. So here we go. We're going to put 2 into the equation. 2 squared, that's 4. So we're going to go to where 2 and 4 meet on the coordinate plane, and we're going to go make a red dot. And we can keep doing the same thing. For example, -1.9. -1.9 squared is equal to 3.61. So we're going to go to where the x value is -1.9, and we're going to go to where the y value is equal to 3.61, and we're going to go to where they meet, and we're going to make a red dot. And there is our coordinate. Now I'm going to keep doing the same thing, so I'll shut up and I'll let you follow. And then after all of those red dots we drew, we can finally connect all of those dots, and then you'll see that this is the graph of a parabola, and we drew it by using coordinates. Now back to this. This is a function. What we just drew now, that's a function. Why? Because when we put in 3, we only get one answer. We don't get 9 and 12 as our answer. We don't get, for example, if I had to erase the 3, and if I had to put in what? A 5. 5 squared, that's 25. I'm not going to get 25 and 26 at the same time as an answer. It's just one answer. 25. 25, that's our answer. For example, 10 squared, that's 100. Okay? 6 squared, that's 36. It's not 36 and 43 or 36 and 9, whatever an answer. It's just one answer. One input, one output. Like a vending machine. Going to a vending machine, pressing the Pepsi button, I'm gonna get a Pepsi out. If I press the button twice, I'm gonna get 2 Pepsis out. All right? I'm never gonna press a Pepsi button and all of a sudden I get a Pepsi and a Coke. Or I get a Coke and a Sprite from a Pepsi button. It doesn't make sense. Okay, so Coke button gives me Coke. The same way, if I put in 5 squared, I get 25, just one answer, one output. Okay, now what's an example of something that's not a function? Y is equal to plus minus the square root of x. You can graph this, okay? But this is not a function. Let me show you why. Let's choose a number, choose a 4. Let's put in the 4 there. All right, in place of the x, we put in the 4. What's the square root of 4? It's 2. What does this mean? This means that the answer is positive 2 and negative 2. How can that be? That's not a function. I mean, think about it. We put in just one number. We put in 4. That's all we did. But we're getting 2 answers. We're getting positive 2 and negative 2 as our answer. Cannot be. That's not a function.
So there's our coordinate plane, and there's our equation, plus minus the square root of x. And as you can see, if you put in one x value, you get 2 outputs, 2 y values. And if you continue, you get 2 red dots over the same x value, because you get 2 answers from one x value. Okay, if you continue, we get plus minus 2.24, and if you continue, we get plus minus 2.45 for the x value of 6. So if we had to connect all of these dots, you get a nice sideways parabola. Although it looks nice, this is an example of something that is not a function because it fails the vertical line test.
And I'm going to demonstrate this non-function with a circle. Now, x squared plus y squared equals 4 is the equation of a circle, but I chose that equation for this particular case. That's not an equation for every circle, okay? It's just for the equation I'm about to demonstrate to you right now. Now, if I put in 2 into the equation you just saw a couple of seconds ago, you're going to have this. Now, let's solve this, okay? 2 squared, that's 4, plus y squared equals 4. Now move the 4 to the other side, so that's going to be 4 minus 4, all right? So we have y squared is equal to 0, and the square root of 0 is just 0. So y is equal to just 0. That's our final answer, okay? Now we can do the same thing with negative 2, all right? Let's just change that. So negative 2 squared, it's still 4. 4, move this 4 to the other side, it becomes negative 4. All right, over here. If you move this 4 to the other side, negative 4. 4 minus 4, that's 0. Same thing. You get the same answer. Let's see what happens with other numbers except negative 2 and 2. So, what did you notice? You notice that other numbers, when you put in other numbers, you always get a plus and minus an answer, which means there's 2 answers. For example, if we use 1, let's use 1, all right? We're going to solve it together. 1 squared, what's 1 squared? That's just 1 plus this plus that. Now, if you move this to the other side, you're going to get y squared 4 minus 1. And then that's going to be y squared 3. All right, equals y squared equals 3. Now, if you take the square root of, I'm going to write it over here. Now, if you take the square root of y, you're going to get the square root plus minus of 3. That's 2 answers. We're going to have the positive square root of 3, which is 1 answer. And then somewhere below that, exactly on that line, or that vertical line, like somewhere below, we're going to have the answer of negative square root of 3. So how can that be? We only put in 1 input, but we keep getting out 2 outputs. That's an example of something called a relation, like I said a couple minutes back, not a function. This is a relation, all right? Now remember, a function is a type of relation. Every function is a type of relation, but not every relation is a type of function. In order for something to qualify as a function, it needs to be like that first function we drew, that parabola. You put in, for example, 2 and you get 4. One input, for example, all right? But if you put in one number and you get multiple numbers out as an answer, that's not a function, that's a relation. A nice analogy of this is, I'm black, maybe you're white, maybe you're Asian, maybe you're Indian, all right? We all we're all different, but we are all humans. So a relation is a big umbrella that functions sit under, but not every relation is a function. Okay, remember that. Now we can get to the vertical line test. The vertical line test says that if you have to draw a vertical line anywhere on the coordinate plane and it touches that curve, any curve, more than one place, that is not a function. But if it touches that curve not more than once, it is a function. I'll show it to you right now. Now, if we had to draw a parabola and we have to draw a straight vertical line, okay, this white line, if we had to scan this white line all over the parabola, okay, you can see that the parabola and the white line are only touching at one point. We can use a green dot for this. Look at the green dots. Look at the green dots, okay? The white line is going straight to the parabola, but it's only touching at one point. It's not like the circle we did in the previous example, okay? Now, let's remove the white line. Turn the parabola this way. Okay, let's do the same thing. Watch the white line. It's going from right to left. Boom, touches once. We good. Oh no. 2 red dots. But see, I saw a point on the graph where the vertical line only touched once before it touched multiple places. Yes, I saw it too, okay? But that does not mean the vertical line test passes. Look, even if there are a million places where the vertical line touches the graph even just once, even if there are a billion places, if you can find just one place where that vertical line touches the graph more than once, it fails. The whole test fails. You can rewind, okay? Rewind and watch it again. You're going to see that on that graph, on both of those graphs, all right, there are some places where the dot is green, like my mic here, and there are some places where the dot is red. Let's use this one. Straight, it's going, it touches, okay, there's a green dot, oh, 3 red dots. It's touching at 3 places, okay? It's not supposed to do that. That is not an example of a function. That is a relation. Look, I'm gonna close my eyes, okay? I'm gonna go mark in my hand, I'm gonna close my eyes, all right? I'm gonna draw a random curve. And then we're going to use the vertical line test to see if it's a function, if it's a graph of a function or not. Okay, close my eyes. Okay, now that's a weird curve, all right? But we're going to use the vertical line test. So let's draw a vertical line. Touches the graph only once, there. Touches the graph only once, there. Oops, touches there, there. It fails. That is not the graph of a function. I don't care what the equation for this was, okay? I just know this is not the graph of a function.
Now here's a test for you. Which of these are graphs of a function and which are just relations? And one more test for you is the vertical line itself that we keep talking about so much. Is that an example of a graph of a function or is it just a relation?
Voila! Now you know what the vertical line test is. If you liked the video, please consider subscribing. It really helps the channel. But if I'm never going to see you again, I hope one day we meet for one more lesson. Cheers.